Hi everyone, I am Vaidehi. I am an assistant professor from AIML and IoT department. So in this video, I would like to tell you about one more component of big data, that is MapReduce. In our previous videos, we have discussed about HDFS, which is one first component of the big data, and MapReduce. This is the second component and the very most important component of the big data. We will be discussing that. So what is MapReduce? MapReduce is a software framework that allows the distributed processing of large data sets across clusters of computers. Across group of computers using simple programming models. That means using simple programming models, group of computers which process distributed large data sets that are processed using MapReduce framework. So MapReduce is designed to scale up from single machine to thousands of machines, which will be offering different level of computation and CPU storage. So there is a simple example of MapReduce. So if you consider word counter example of MapReduce. So what is word counter example? Let me explain you about what is word counter. So there are 100 books. In that books, your manager asked you or your superior asked you to find out how many times success word is there. So this is word counter, right? So using HDFS, what we will do, we will these 100 books, we will divide it into 10 books for each person, and we will hire 10 persons. So they will perform their distributed computing system, and with that they will give us an output. Right, this first person will give an output, second person will give third, fourth. So all these different persons will give different kinds of output. So how this output, like how the internal process has been happening, like how the search has started, how the work has happened, and how the output has been generated, that flow is happened using MapReduce algorithm. So there are different steps in MapReduce. So first one is input, and next split. Third step is mapper. Fourth step is shuffle. Fifth is reduce, and then we will get output. So what are the 6 phases in MapReduce? First one is input, second one is split, third is mapper, fourth is shuffle, fifth is reduce, and sixth is output. So how can we explain, like in the real world example, how these phases are useful? So input. What is the input? Success is not a story. Success is definition. So this is the input. Okay, this is the input. And how the mapping will happen here? So each one will be divided into like one block kind. So success is not, success is def. So in this way it is divided. So this is what? Split. This is the split stage. The data, the input data here, it got split into different blocks. So after splitting, what will it do? It will shuffle and sort. So how many times, as ours is a word counter example. So we are just counting the words, right? So how many times here there? Success 1. In 1. Success 1. Is 1. Definition 1. So what in the splitting, in the shuffling stage, what will it do is just shuffle the words. It just count the words. It will not count, like each word will be said 1, 1, 1, 1, 1. But if success is 2 times in this sentence, it will not write as 2. It will write as only 1, 1. In that way only it will write. Okay. So this is the shuffling stage. And next, sorting. In sorting, what will it do? Success 2 times. In, how many times it is there? 1 time. Is, how many times it is there? 1 time. So in this way it will just sort and reduce. Okay, it will sort and reduce how many times the words are there. And in the output stage, in the last stage, so we will get output as, our main example is what? How many times the word success is there. So in the output it will give success 2. In this way it will give us the output. So these are the 6 different stages: input, split, shuffle, sort and reduce, and output. In this is the process. The algorithm works in this way, as I have explained, and it will gives us the output. So why is this important? Why is this important? Because, so if 10, as we discussed, 10 people are working on tasks. So this person got success word 10 times, and the first person, second person got 20 times, third person got 30 times, fifth person got 80 times the word in that particular book. Then how many times the output will get to the user? So all the 10 10 persons who are performing the task, all the 10 persons will give output to the client, right? Client, suppose client is me. So all the 10 persons are giving output to me all the 10 times, which causes lot of traffic, network congestion. So with traffic, what? The data which used to be delivered will get delayed, and when the user asks the client any data, then to send the data, the client get delayed to send the data. So all these will happen. So rather than sending, the main reason is, main question is, I want word counter success, how many times it is there. That is the problem statement. So I only want how many times the success word is there. On an average, I want the last answer is, it is there 10 times. Okay, that is fine. Like, not, but all the 10 inputs, all the 100 people who are working, all the 20 people who are working, they need not to send me the output for the client, right? So that's why we perform here MapReduce operation for this HDFS, or for this data distribution. In all these 6 phases, input, split, sort, shuffle, reduce, and output. So in this way the MapReduce algorithm works, and it will send the client direct output. So the word success is 10 times. This is the only output the client will get received from the user. In that way there will be no network traffic, there will be no delay, there will be no load balancing issues, and there will be no fault tolerance, and there will be no network issues as well, right? So that is the main reason for using MapReduce algorithm. So this is the algorithm. These are the different phases which work on the distributed file system, HDFS. So this MapReduce, why it is important, as I said, is for the simple example only, it is taking this much of time or this much of network traffic and everything if we do manually without MapReduce. If you consider the Amazon, or if you consider Google or Netflix, such type of large companies, huge companies, how much data will they expect, and how many clients they have, what would be the data latency, or what would be the network or traffic issues if MapReduce algorithm does not perform, and each client, each user will get delayed, right? With that, there will be downtime of the application. With downtime of the application, there will be millions of users lost for that particular application, and there will be huge amount of loss will be discovered. For that, MapReduce algorithm is important. So here there is one more thing called HBase. This is not a big data component, but this is very much useful tool in the Hadoop ecosystem. Okay, HBase. HBase is an open source, non-relational, SQL distributed database modeled, okay, to store the big data. To store the big data, HBase is designed. HBase have a query language called Hive query language. It is same like SQL. in the DBMS, which we learned or usually, which everyone know usually, structured query language. The same way, Hive query language has been designed for big data particularly. For that, HBase is required to perform Hive queries. HBase is required. Okay, how for structured queries, how we can perform on DBMS for all the databases and everything. Hive query is particularly designed only for big data, to store, retrieve the big data. There is no much difference between HQL and SQL. Both are same. Like both perform the main CRUD operations: create, read, update, delete. All these 4 operations are performed in SQL, and the same operations are also performed in HQL, Hive query language. The main difference is that this Hive is designed only for the big data, where SQL is not. SQL is designed for every data. Hive is designed only for the big data, because to process the data very fast. And the queries or the logic behind Hive query language and structured query language are same. There is no difference. So if you see a query, you cannot identify that is it a structured query language or it is a Hive query language, because the query will be same for both the languages. The only difference makes is that Hive query language can be used on HBase, which is designed for specifically big data, where SQL is not specific for big data. So Hive can be performed only on the HBase. That is why Hive query language is used for the big data exclusively. So see, Hive. Hive is a data warehouse infrastructure built on Apache Hadoop for providing data summarization, data querying, data analysis, nothing but data creating, data reading, data update, data retrieve, data delete. So for all these operations, Hive query language is designed, which is performed only on the HBase, specifically for big data, unlike SQL. But both SQL and HQL look same. So I hope everyone understood what is MapReduce and the importance of MapReduce algorithm in the big data, and why do we use MapReduce, the significance behind using MapReduce. I think everyone has understood that, and as well what is Hive also I have been explained in this video. I hope everyone understood Hive, the difference between Hive query language and SQL query language. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.